Hey guys! So today we're going to talk about potential energy. And again, this is a review for some of you, but brand new for others. So potential energy is defined as the energy based on height of an object. Now in my class we also talked about elastic potential energy, but we're not going to focus on that today. So we are only focusing on how tall or how high something is in relation to the ground. So objects must have mass, and they must be a height off of the ground to have potential energy. Now, the ground can be a relative idea. If we're inside of our house, it's obviously not going to be on the ground outside. It could be on the floor of the second floor of the building. But that's still going to be our 0 point within that classroom. Now, could something fall through the floor into the floor below? Absolutely. But that's going to be a rare case in terms of what we are going to be doing. So we have this potential energy equation, and again, PE stands for potential energy, and that's measured in joules. M stands for mass, and that's measured in kilograms. G stands for gravity, and that's 9.8 meters per second squared. And H stands for height, and that's measured in meters. So notice, all of these have their units and these units are specific. Make sure that you are converting to those units in order to do your math. We shouldn't be looking at a mass in grams or a height in centimeters or inches. Everything does need to be converted. So now we're going to look at two different books on this bookshelf. I picked the two most similar ones so we're able to actually compare them. Of these two books, the one in the bottom down here, this one, and the one in the top, which one has a higher potential energy? And that's going to be the top book, because it has a higher height. So the height is bigger. So since that book is further off the ground on a higher shelf, even though it may be the same size as the other one, it's going to have a higher potential energy. But how could the books have the same potential energy? Now again, I picked two of the most similar books I could, so we're going to assume that they have the same mass. So in order to have the same potential energy, you would have to put them on the same shelf. They would need to be the same height off of the ground. So now we're going to look at a potential energy example. We have a 60 kilogram person walking from the ground to the roof of a 74.8 meter tall building. How much gravitational potential energy does he have? So notice, we have the PE, M, G, and H all from our equation, but only two numbers are given to us in that write-up, in that equation, because we can always assume that on Earth, gravity is going to be 9.8. Now we know the further away you are from sea level, the more it can differ, but it's never going to differ enough for it to actually affect our calculations. So gravity is 9.8, automatically just plug it in. Now the mass, it states, is 60 kilograms, a 60 kilogram person, and the height is 74.8 meters. So our big fat question mark is our PE value. So we're going to write PE equals mgh. Then we're going to plug in our numbers. PE equals 60 times 9.8 times 74.8. And then with this one, we don't have to worry about order of operations like we did with kinetic energy. Multiplication is universal. We can multiply the first two numbers together, then the third, the first and the third, and then the middle. Doesn't matter. It's all going to math out the same either way. So all we have to do is type in our calculator 60 times 9.8 times 74.8, and we get a value of 43,982.4 joules. So again, when we return to school, you may have to do some sample questions or problems like this. You may see these on the quiz at the end of this little unit that we're doing before spring break. I want you to see these examples so you would be able to answer some questions. All right, talk to you guys soon.